Hello, my name is Dury Long. I am a human-centered computing PhD candidate working in the Expressive Machinery Lab at Georgia Tech. And today I'm going to be discussing a paper that I wrote in collaboration with my co-authors, Tom Macklin, Anna Weisling, William Martin, Stephen Blow, Caitlin Boravong, and Brian McGurko. Our paper is entitled Out of Tune, Discord and Learning in a Music Programming Museum Exhibit. Discord, a term we use to refer to social conflicts such as disagreement, interruptions, or disruptions to others' play, often occurs when individuals are collaborating together on a task involving shared resources. Prior research suggests that certain types of discord can play an important role in learning and interest development. There hasn't been much prior research on the role that discord plays in learning about computer science, particularly in informal spaces. In this paper, we investigate how discord relates to learners' intellectual, social, and physical engagement with Toonable, a museum installation designed to encourage learning and interest development in computer science. Toonable is an interactive, tangible tabletop experience where participants can use computer science coding concepts to co-create sample-based music compositions. The table is designed for use by family groups visiting museums and is targeted at middle school-age students and their families. Participants interact with the table by placing and connecting tangible blocks on the table's surface. The table uses a bespoke programming language called Blockhead. There are two types of blocks, sample blocks and function blocks. A sample block spawns a playhead, which when hit will play a sound sample. Function blocks, on the other hand, are blocks that can be attached to chains of sample blocks to modify them in certain ways. For example, the iteration block shown here can be attached to a chain of blocks to loop them. Some additional components of the Blockhead language can be viewed here. More details are provided in the paper. We conducted two separate data collection sessions where we installed Toonable in a classroom workspace at the Museum of Science and Industry in Chicago. In total, we recruited 31 family groups to interact with the table and participate in a short post-interaction survey and interview. Most family groups had at least one child in our target age range, which was 10 to 14-year-olds. We recorded interaction sessions from both a top and a side view. We conducted a deductive thematic analysis of the video data that we collected, guided by the active prolonged engagement framework for understanding participants' interactions at open-ended museum exhibits. We examined participants' physical, intellectual, and social engagement in 10-second intervals. The codebook we developed to understand participants' social engagement consisted of 3 binary scales. The first looks at whether participants assumed an active-passive interaction dynamic. In other words, whether one member took the lead in the interaction or whether they interacted more as equal partners. The second scale looks at whether participants are having discordant interactions or working together in harmony. Finally, we examined whether interactions consisted primarily of independent or collaborative play. We developed 3 codes to understand participants' intellectual engagement. Seeking knowledge highlights moments when participants are attempting to fill gaps in their current understanding of the exhibit's functionality. Sharing knowledge reflects moments when participants develop a mental model of the exhibit and are able to share this knowledge with their group members in the form of observations or explanations. Applying knowledge describes moments when participants demonstrate that they have a strong understanding of the way the exhibit functions by applying and relating their knowledge to the exhibit. For example, proposing a solution to a problem. Physical engagement refers to the ways in which visitors interact physically with an exhibit by engaging in hands-on manipulation of the tangible aspects of the installation. We use the code isolated manipulation to refer to moments when participants are physically interacting with the exhibit, but only with isolated components. Investigative manipulation refers to moments when participants are beginning to methodically explore how the exhibit works using physical means. For example, in the case of Toonable, chaining together multiple sample blocks. Finally, integrated manipulation refers to moments when participants are physically manipulating aspects of the installation in a complex way. For example, connecting both sample and function blocks. While learning and interest development can occur in any of the types of intellectual, physical, or social engagement I just described, we see the combination of integrated manipulation, applying knowledge, and collaboration as being particularly conducive to and demonstrative of learning. Our statistical analysis of the coded videos, described in more detail in the paper, revealed that there is a significant positive relationship between occurrences of social discord and the desired interaction that I just described. This indicates that discord may be a marker of deeper physical, intellectual, and social interaction. In order to further investigate this phenomenon, we looked through all of the instances of discord that occurred during participant interactions with Toon and we classified them according to different types, which I will describe in more detail in a moment. Some of these types of discord were productive, meaning that they have the potential to inspire new creative directions, foster collaboration, or spur a cooperative discussion of ideas. Others were less productive. In other words, they don't clearly lead to opportunities for learning or interest development. The first type of discord that we identified was conflicting goals, which we defined as discord resulting from group members who had different goals for what they wanted to create or learn. Discord resulting from conflicting goals can lead participants to potentially collaborate and explore new creative directions, learn about computing concepts and exhibit components, and create more structured and goal-oriented learning experiences, making it a productive type of discord. We also observed discord arising as participants were learning about the different function blocks on the table and presenting opposing hypotheses as to how the table and computing concepts worked. This type of discord is productive due to its potential to spur cooperative discussion. Certain moments of discord were caused by group members that tried to take control over whatever action was happening on the table. Our observations indicated that these interactions were usually brief, physical rather than verbal in nature, and seemed to be driven more by frustration with other group members than a coherent plan, thus indicating that this is not a productive form of discord. Some conflicts occurred as the result of limited space or materials. The potential for limited space or materials to inhibit the exploration of new creative directions or cause competition over resources suggests that this is a form of unproductive discord. Finally, there were a few instances of disruptive distractions that appeared to be both unproductive and not indicative of deep engagement. These often happened when groups were too large or a younger member messed up the compositions on the table or demanded frequent attention from adult group members. Reflecting on these findings suggests a number of different implications for designing and evaluating computer science learning experiences in museums. First, our findings suggest that discord is indicative of a high level of participant engagement with the computing concepts embedded in Toon. This suggests that discord could be an important marker to look for in CS-related exhibit evaluation in the future, indicating high engagement or learning dialogue. Our analysis of discord types suggested that discord resulting from conflicting creative or learning goals may be indicative of a particularly high level of engagement and may be able to productively contribute to learning. However, on the other hand, conflicts resulting from limited space or materials or disruptive disturbances from younger group members may hinder creative progress or learning. Thank you so much for your time, and if you have any questions, make sure to check out the full paper or reach out to us.